So today we're going to talk about differences between scalars and vectors. Now you may have come across this before, so the definition for a scalar is something that only has magnitude. And what that means, it has some numerical value, and that's just it. It just has a number. Vectors are something that have both magnitude and direction. So this can be a number followed by an angle, maybe a positive and a negative sign, something like that. Some examples of scalars, we can say time, distance, mass, speed. These are all scalars. These have only a number. So your time can be a certain number of seconds, distance a specific length, mass is just your mass in kilograms, your speed is just a number. Some vectors, for example, could be velocity. Velocity is the vector version of speed. It's the magnitude of a speed in a particular direction. And you can also say the same for distance. The displacement is sort of the vector version of distance. It is the straight line distance between 2 points. Whereas the distance, if you let's say we were going between A and B, you took this random path here. To measure along this exact path how far that is would be measuring the distance. But this distance straight from A to B is your displacement. Because you're measuring it in that particular direction only. Some other examples of vectors can be force, acceleration, and moments. So let's say you were given a vector diagram, so let's say a force diagram, and you were asked to resolve these forces or resolve the vectors. Now it's not really common for you to resolve it through diagrams and scalings, but it might be a worthwhile skill to learn. Now if you were asked to find the resultant force, the more typical way would be to solve it using calculations and equating horizontal and vertical components, which we will go through later on today. But another way to do it is also by drawing a force diagram, and sometimes it may ask you to do this in the exams explicitly. So how would you do it? Well, first of all, you pick a direction. And you pick your first force. So let's say I'm going to start with this 6 Newton force, and I'm going to work around all the forces in the anti-clockwise direction. So let's start by drawing the 6 Newton force. And the things you have to make sure is you have to draw everything to scale. I can't really draw it to scale here, I don't really have a ruler. But when you're doing it, you make sure you're always using a ruler and using a scale. So let's say in this case, you could use a scale of 1 centimeter for 2 newtons. So I'll draw a 3 centimeter line here to represent that 6 Newton force. And the next force that comes along is this 10 Newton one, and that's directly upwards. So that will be of length 5 centimeters. And then you also have the 20 Newton one is the next one, so you're going around this direction, 20 newtons, and that's going to be 10 centimeters. That'll probably go all the way along there somewhere, 10 centimeters. And your last one is this 12 Newton force, in which case you have to get out your protractor, find the line at which it's 30 degrees, and you draw a 6 centimeter line to represent the 12 Newton force. And then you have your 2 points, your start point here, and end there. And you simply connect it up with a line. You want to measure the distance or the length of that line. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.